Hi, this is the solution of Enteric coated tablets, experiment, calculations and data analysis. As you remember, our objectives were to test the claim of the company Dar الدواء that diclogesic 50 mg tablet, diclofenac sodium tablet is enteric coated tablet by performing USB dissolution method testing into two stages, the SGF and the SIF. And our calculations objective was to plot a multi-point dissolution profile of diclogesic 50 mg diclofenac sodium enteric coated tablet that represent the two stages on the test. To do so, we have to remember that multi-point dissolution profile is a plot of percent dissolved, or also known as percent released, versus time, and usually we are using time in hours, as you can see in the figure. To do so, we have to use our calculated numbers. First, arrange your data in a table similar to what you can see here. To be able to plot a multi-point dissolution profile of the two stages, we have to calculate or determine the dissolution time. As you can remember, the first stage time, which was the SGF stage, was 45 minutes. Then the same tablets was used in the second stage. Then, if the tablet spent 5 minutes in the SIF stage or in the SIF medium, the total dissolution time should be the time from the first stage, which was 45 minutes, as we mentioned, and 5 minutes in the SIF stage. The same is done for the other sampling times. Again, the sample that has been taken at 15 minutes in the SIF has spent also 45 minutes in the SGF. Then the total dissolution time is 60 minutes. Do the same for all other sampling time in the SIF. Then calculate the time in hours. This is simply can be done via dividing the time in minutes by 60. Now add the dilution factor. Always dilute samples with absorbances more than 1.2 with a suitable dilution factor, and dilution factor will be equal to the final volume divided by the initial volume withdrawn from the sample. To calculate the concentration of the sample, use the calibration curve equation provided by your instructor. As you can see, the concentration in the calibration curve equation is used as milligram per ml. Here, the concentration is equal to 100. This is used to transfer or to change the concentration unit to be milligram percent. Add the y-intercept as it is negative in the original calibration curve equation, then divide by the slope. Again, we multiply it, the concentration, the calculated concentration, by 100 to change the unit. The original unit was milligram per ml, and as you can see, we want it to be calculated as milligram per cent. Remember, if you did dilute your sample, please multiply the concentration, the diluted concentration, by the dilution factor. Here is the vessel concentration, or the sample concentration before dilution, the undiluted concentration, which is again equal to the concentration times the diluted concentration times the dilution factors. Here we assume that the dilution factor will be equal to 1 when we didn't do any dilutions. Now, calculate the amount in the 5 ml sample, the sample size. Notice here that we will need this amount to calculate the total amount dissolved. And notice also that this can be changed to another sample size. If your sample size was higher or lower, please use the exact volume of your sample size in the calculations. Now, we will calculate the amount in 900 ml, and 900 ml is the total medium volume we used in the vessel during testing. Then, how to calculate the total amount dissolved? Notice here that this amount calculation will differ based on the sample time. For the first sampling time, the total amount dissolved is equal to the amount in 900 ml, while for the second sample in the SGF stage, the total amount is equal to the amount in 900 ml at the same time plus the amount in the 5 ml sample at the previous time in the same stage. While the total amount dissolved at the first sampling time in the second stage, the SIF stage, will be equal to the amount in 900 ml at the same time plus the total amount dissolved in the previous stage. As you can remember, the medium has been discarded after the first stage finished. Then anything in the medium will be lost. So we have to add it to all samples in the second stage. While the amount in the second sample withdrawn at the second sampling time in the second stage SIF is equal to the amount in 900 ml at the same time plus the amount in the 5 ml sample in the previous sample in the same stage plus the total amount dissolved in the previous stage. Again, the amount dissolved in the third sample withdrawn at the third time in the SIF stage is equal to the amount in 900 ml at the same stage plus the amounts in the 5 ml samples at the two previous sampling points in the same stage plus the amount totally dissolved or the total amount dissolved in the previous stage. Do the same for the fourth sampling point in the SIF stage. To calculate the percent dissolved, as you know, percent dissolved or percent released is equal to the total amount dissolved divided by the claimed or labeled amount times 100%. Here we have the claimed amount equal to 50 milligrams. Then the percentage dissolved will be equal to the total amount dissolved divided by 50 times 100. Now, you can plot your multi-point dissolution profile. Plot percentage dissolved versus the time in hours. Please use scatter, smooth lines and markers type of charts from your insert menu. Add the chart title, and the axis titles, and please from shapes or use shapes to title each stage. This is how your dissolution profile should appear. Please remember that the numbers we are using here are hypothetical numbers. Now, build up your portfolio pages. Use the same method we used in previous cycles. Use Word page with layouts with the layout we discussed previously and used in the previous reports. Then, just copy and paste Excel tables and charts. Always start with the results tables, raw results tables, then calculations and data analysis. Here are some questions for you to answer. All of these questions were discussed previously either in Pharmaceutical Technology 1 practical sessions or during your practical sessions this semester. Here are some notes on sampling. Thank you all.